Perfect. Yes, my name is Philip Wehrens. I work as a geologist at the Swiss Geological Survey, and today I would like to present the GeoBIM project. The GeoBIM project is a collaboration between the Swiss Association of Geologists, the University of Applied Sciences, and the Swiss Geological Survey, and is partly funded by the Swiss Innovation Agency. And as we've seen before in Mikael's slides and also in Hilka's slides, the relevance of BIM and what it's doing is creating a shared platform for people working in civil engineering, for example, to share data, share models, and work on one specific set of data as well as visualization. And so far, geology has not been really part of that. And the goal of this project is to integrate the geology into the BIM method, mainly to be able to promote cooperation and communication of geological data. And for the Swiss Geological Survey, one of the main interests is the standardization of geological data, which is a prerequisite for the integration of geology into the BIM method. Apart from the three groups I mentioned before, there's also an advisory group involved in this project, which consists of members from private industry and also federal, local, and semi-governmental organizations. And they are partly suppliers of geological data and partly requesters of geological data. And they are really important in making sure that this project has a usability in practice. And this is just a quick overview of the project we have. We started out with an interview phase and simultaneous creation of fundamental reports, after which we could do a redefinition of the scope of the project. Then those advisory group members supplied us with data and use cases to try out the developed method and ideas. With retrospective projects, so the projects were already finished, but we could use the concept behind it. And then this is where we are at the moment. We're still working on that. And then after that, we will make our results available. Tools which are generated, etc., will all become available. And we will all also make an educational concept, especially for the members of the Swiss Association of Geologists, to be able to understand and use what we've created. The project has a time span of 2 years and started in March of 2020 and will finish in spring next year. First, a look back to what we've done so far. So we've created 2 fundamental reports dealing with, on one hand, geology, where we've looked at what is important in terms of geology with relationship to BIM. So that deals a lot with norms and standards, and also 3D models is an important part, of course, data models as well. And on the other hand, we've created a fundamentals report for the BIM method, which then focuses on the exchange of information, on the differences between GIS and BIM, and also IFC and industry foundation classes as a format, because it's an open format which allows data to be displayed in any BIM viewer. So that's an important prerequisite that we use IFC. And also it deals a lot with data models, also geological data models, international as well as national, and makes kind of a comparison. You can download these documents under the website you see there. Unfortunately, they are in German. I think with Urban Geology Group, there are some copies available somebody made in English. So just using a translation tool, but at least there you can find the original and translate it if needed. The other thing we did in this first phase was have an interview phase with the advisory group members and to see what is actually handed over from the supplier, the geologist in this case, to the requester. What kind of information is that and what phases of a project does that take place? And the main conclusions or what the findings from that interview phase were that people work a lot with reports, PDF reports with cross sections as PDFs, boreholes as PDFs, sometimes also as vectorized data. And 3D models exist, but they're not super common. so they exist, but it's not like every data set consists of multiple 3D models. Then standards are being used, national as well as international standards for geological and geotechnical data. Data models, however, are more organization specific. So they are being used in some cases, but then they're really limited to that specific organization. There are various disciplines and areas of interest that we've also seen in Michael's contribution, where geology plays a role and where these advisory group members are active. And data comes in various types and formats and various representation forms. And there's also a large spectrum of geological expert software which is being used with different data formats. And then another consideration to make is that we are limited to what IFC has to offer in terms of support for geological data, because that is a choice we made at the start. And we're also dependent on the functionality of IFC capable viewers. Okay, so with that in mind, we limited the scope of the project to 3 specific areas of application, as you can see here. So mainly in the geotechnics and natural hazard discipline. And we also focused on these representation types of geological data, so measurements, boreholes, cross sections, and 3D models. With the added thing I should add about the cross section is in this image below, you see the classical cross section on the top. And then on the bottom, there's a standardized way of how those cross sections are made, with more domains being defined along the tunnel axis, which comprise of geological and geotechnical information. And that is really important information which needs to be transmitted to such a BIM environment. And then 3D models, there we've looked at voxel models as well as surface models, where closed surfaces then represent a volume. And as I said, there's many different attributes and parameters to consider, but we've tried to limit those to what is essential for the requester. And it goes also in the same kind of vein as what Michael has shown. So how can we implement such a thing? From the geological side, information is supplied in various standardization formats, depending on the data type, the data format, what is the data form, so is it a borehole or something else. Then there are many kinds of proprietary software being used with data formats which are also fixed. And these are things we cannot really change, there's no influence to be had. And the output which we want to generate is IFC, and also there's no direct influence we can have. So what we need to do is find an interface which takes that information, requires it to be in a certain structure, which is then the GeoBIM data model. With that, it is harmonized and can be used in a transfer service for integration into IFC. So that is the concept and the span of the scope of GeoBIM. And we've implemented, or we've tried to implement it using the use cases of the advisory group members, where we've paired up suppliers and requesters of geological data. And we could come up with 3 kinds of modules so far. The first one is boreholes / tunnel axis, tunnel band information. Then 3D surface models of both the closed and open surfaces, and then 3D voxel models. And you see those yellow boxes, they are the actual transfer service, which is a Python script which takes that information and turns it into an IFC attributed object. And boreholes and tunnel band is put together because basically a tunnel axis is nothing more than a non-vertical borehole. So the data is structured in the same way we found. And also we've kept it relatively easy by using lots of standard data formats. So Excel is basically all you need. For boreholes and 3D voxel models, the geometry is incorporated into the Excel file per definition on how it's stored, because the geometry of a borehole is stored in an Excel file by its coordinates or by a direction and azimuth, and the information, the actual geological information, is in the same document. With surface models, it's a bit more complex, so there a DXF does not allow for attribution. So there an additional Excel file has to be provided in order for the thing to work. It is assumed that the data then fits with the GeoBIM data model, which is very limited to the scope of what is needed for GeoBIM. It incorporates the limited scope, and the attributes belonging to that are then looked at in terms of Swiss standards, and they're related to GeoSciML to make sure that it's has a connection to that. Where GeoSciML does not goes not far enough into geotechnical detail, for example, AGS has been looked at, and the whole basic structure of the data model is GeoSciML based, so it has a very strong compatibility with GeoSciML. Yes, also the tool is based on IFC OpenShell, and the rest I've mentioned, I think. And the last thing, if a new IFC version would allow for the better handling of geological data, then only the last interface at the bottom one we would have to change. The rest can remain the same. So that's also good to know. But this is still, as I mentioned, work in progress. We can look at an example of how we try to implement that. So this is the same profile again. And in this case, we also have a 3D model along the tunnel axis, which we want to convert to a BIM software, and we also want to use the tunnel band information. So those geological domains at the bottom, we also want to get those into an IFC viewer. And then we can use the previously described modules to do that. And in the top image in the green, you see a geological surface, a closed surface, which represents volume. And using that tool, we can attribute that with various attributes. In this case, it's not yet according to the GeoBIM data model, the attribution, but that is, as I mentioned, still work in progress. And on the left, you see on the left bottom, you see the tunnel axis displayed. It's rendered as a tube. And each segment along the tunnel can be selected, and attributes belonging to that specific norm or standard can be shown. So that also shows that how that implementation, what it would look like. And that's where we're still working on. So that means for the future, we have to look at our data model and integrate that also into the tool to a further degree. We haven't looked at measurements yet. That's still, we have looked at it, but it's not yet finished. We're still working on that. Also, the idea is, instead of having just a Python script, is to have a web service where you can upload your data, select whatever you need with a user-friendly interface, and then transfer your data so it comes back to you in an IFC format. And then, as I mentioned at the start, we still then at the end need to put everything together, make everything available in terms of documentation and tools, and provide an educational concept so people can work with that. And at the bottom, I still have some links to useful sites relating to this project. So that's it from my side. Thank you.